We're here at ARC World Forum in Orlando, Florida. I'm pleased to welcome Editor Emeritus of Supply Chain Brain, Jean Murphy.
Hello. Today I'm speaking with Ralph Rio, a Research Director at ARC Advisory Group. His area of expertise includes software for enterprise asset management and field service management. Welcome, Ralph.
Howdy.
Tell us, why is software for enterprise asset management so important for industrial organizations?
Well, number one, there's a lot of assets in a plant. We sometimes think of our own homes or our cars as just a couple of items. Scale that up to an entire plant where there's tens of thousands of pieces of equipment with hundreds of thousands of components. How do you decide what's most critical right now to be repaired? The EAM systems gives you the visibility to see what's going on and to understand what needs to be repaired. We've done a lot of research among end users, and the biggest, most important metric for maintenance managers is equipment uptime. Equipment has to be running, available, so that they can meet their customer commitments and make the products and ship them on time. So equipment uptime is a primary metric, and the maintenance managers use the EAM system to allocate their people, their workforce, make sure they have the right spare parts available so they can repair the equipment.
And is this used for preventive maintenance as well as when something actually goes down?
Yes. Our research has shown that roughly 60% of the work orders are for preventative maintenance, various types of preventative maintenance. 30% roughly are for more urgent type things, unexpected repairs. And about 10% is for projects when they're replacing a piece of equipment. So that's a good thing that most of it is for preventative maintenance.
And how does this relate to or differ from field service management?
Yeah, we normally think of a plant as being one contiguous site. So there's equipment in the plant, various operations going on in an area. In the case of field service, now we're thinking of assets that are beyond one site. So there's assets that could spread along a wide geography, and they may be also in a customer's site. So now functions that have to do with improved customer service becomes important, and features like geography, maps, integrated, and GIS information, so you can do routing optimization. As the field service technician goes from site to site, how do you minimize their travel time? But it gets very complicated. That isn't just it. You may also have emergency things come up in the meantime, so you may have to change that route more dynamically. And since you're doing customer service, things like billing start to become important. And also, there may be an opportunity to do some upselling. So while you're servicing a piece of equipment, you may want to sell them, offer them a service contract type of things. So there's additional areas of functionality that layer off of this customer service metric.
And this will also help them determine what parts to keep in stock on the truck and so forth?
Yes. So that's a good point. Inventory management takes a little bit of different dynamic. In the case of a plant, you got plenty of room to store inventory. In the case of a truck, it's fairly limited. So having the parts that are needed for that particular route that day becomes critical.
I know at ARC you do a lot of best practices research. Can you give us some examples of best practices in these areas?
Sure. We have done, over the past several years, extensive surveys among hundreds and hundreds of users representing tens of thousands of plants around the earth. And we've done extensive best practice work. And one of the better practices has to do with having more of the preventative maintenance and predictive maintenance. Now, most preventative maintenance is done on a time schedule or a number of cycles schedule, like with your car. you change your oil every 5,000 miles. So that would be a good example of preventative maintenance. Predictive maintenance has to do with measuring some sensor, and based on what that sensor tells you, that's an alert that you need to go do something. And an example, a car example of that would be your oil light. When your oil is too low, the light comes on and you better do something about it pretty quick, or instead of just a few dollars for oil, you're going to have maybe a $5,000 engine repair. So that's good predictive maintenance. It tells you that there's something wrong so you can repair it for 10 bucks or so, versus not being aware of it, your engine seizes up and you got a $5,000 or $10,000 repair. We see that growing very rapidly. That seems to be a very more rapidly growing trend over the past couple of years, where the preventative maintenance is being replaced by predictive maintenance, which makes much more efficient use of the workforce and also the materials, because you're doing the maintenance when it's really needed, not just in case maybe I'm going to do something to prevent possibly something happening.
So that impacts both asset management and field service management?
Yes. It's mostly occurring in the area of maintenance management, because the equipment is on the site, you have sensors to it, you have control systems, you read the data from the control systems, and there may be also other independent systems. Read the data, bring it into your EAM system. Sometimes the calculations can be done in the control system or a historian. Sometimes it's done in the EAM system, but somewhere their calculation is done. A favorite example I like to use is a heat exchanger. You got water going in, gets warmed up, goes out. The tubes sometimes get clogged. Corrosion can occur in there, and you've got to clean them out every so often. Well, the preventative maintenance approach would be, let's say every 3 months, you take the thing apart, you look inside the tubes, decide whether or not they need to be cleaned. You have to take it down, apply a lot of labor to decide whether or not you need to do maintenance. With the predictive maintenance, two pressure sensors, one on the inlet, one on the outlet, measure the pressure difference. When it starts going up, you know there's something wrong with the tubes. Simple. Then you do the repair, and you may need to do it once a year or once every 6 months. But now you're only taking down that piece of equipment when it really needs to be serviced.
Right. Are there any consistent areas of weaknesses that you see that companies are experiencing in this area?
Yeah, one of the areas that our research shows is underserved. Only about a third of people are paying good attention to their inventory and doing good inventory management practices. And inventory is becoming more and more of a problem lately, because with more rapid technology change, people are replacing the equipment more often. With new technologies, a larger variety of assets. So to serve that equipment, you need more and more parts, more and more inventory. And the general approach is to, when you buy a piece of equipment, order spare parts just in case. Maybe the manufacturer makes some suggestions. You want to be conservative. If something fails, you want the parts available. So there's a lot of just in case inventory in the facility, and inventory is blowing up. There's a person I was talking with, over the past 3 years, their inventory increased 150%. So it more than doubled in 3 years. And that it wasn't because it was a dynamically growing business, it was more because of this upgrades, technology change, new equipment, a variety of technology. And that's unsustainable. That directly affects the balance sheet, because you're taking cash and you're putting it in inventory. The financial metrics that Wall Street uses for a firm would cause people to downgrade the value of the stock. So it directly affects the metrics of the C-suite. And when you affect them negatively, it's not a good career move. So we see a huge opportunity for inventory management. It occurs in a couple areas. First is just part number duplication elimination. So there's a methodology for identifying duplicate part numbers And the way that occurs is you get a piece of equipment from one vendor, has a half-inch bearing in it. Well, they have their own part numbering system. Somebody else sells you a piece of equipment. It also has the same 1-inch bearings in it, but they use a different part numbering system. So you wind up with these duplicate part numbers.
Right.
One client of ours showed me a list, 100, they only had 5 plants, it was a food and beverage company. 5 plants had over 100 part numbers for the same part. You do part number duplication first, and the next step then is the re-examining the min-maxes for reordering the materials. And there's a power gen person decreased their inventory. After doing those 2 things and a little time to use up the surplus inventory, decreased their inventory 1/3.
All right. Thank you so much for being with us today.
You're welcome.
I've been speaking with Ralph Rio of ARC Advisory Group. Thank you for watching.